6,500 cars. 73. Deliveries reached 6,892 units in the last 3 months of 2013. 74. In December 2013, California announced it would give Tesla a US $34.7 million tax break to expand production by an estimated 35,000 vehicles annually from its Fremont, California plant. 75. Tesla announced that production was expected to climb from 600 cars per week in early 2014 to about 1,000 units per week by year-end. 76. Tesla produced 7,535 units during the first quarter of 2014 and expected to produce 8,500 to 9,000 cars in the second quarter of 2014. As of early May 2014, the production rate was 700 cars per week. 77. As of 2015, about 1,000 cars were made per week. 78. 79. Mostly to pre-orders. 35. Musk says he averaged around 20 changes to the S per week. 80. Production of the Model X joined the Model S during 2015. 81. Following a short reconfiguration of the production line in July 2014. 82. The first Model X that didn't need corrections was made in April 2016. 83. Tesla moved some of the equipment to their Tilburg final assembly plant in the Netherlands in 2015. 84. On the 2nd of July 2015, Tesla announced that it had delivered a total of 21,537 vehicles in the first half of 2015. All vehicles were manufactured at the Fremont plant. 85. In May 2016, Tesla raised $1.46 billion in stock, of which $1.26 billion is to prepare production of the Model 3 scheduled for late 2017. 86. 87. Changing from serially producing the Model S and X to the mass production of Model 3 is viewed by experts as a significant step. 88. Tesla stated in May 2016 that it does not have that capability and needs to acquire it. 89. Which it partly did with the acquisition of Grumman Automation in 2016. 90. And purchase of mass production equipment. Whereas the Roadster was delayed by 9 months, the Model S more than 6 months, and the Model X more than 18 months. 91. Analysts estimated in December 2016 that the Model 3 production preparation was on schedule for the second half of 2017. 92. On the 3rd of August 2016, Tesla announced that it was consistently producing 2,000 vehicles per week at the end of Q2 2016. 93. 94. About 2,500 workers operate the day shift and 2,000 attend the night shift. 43. Tesla makes many parts itself, which is unusual in the auto business. Tesla also works with 300 suppliers around the world, of which 50 are in Northern California, and 10 in the San Francisco Bay Area. 95. Tesla's dashboard supplier SAS rents a 142,188 square foot building near the factory, beginning in January 2017 with 200 employees. 96. Other suppliers that have opened facilities in the area to be close to Tesla include Eclipse Automation and Futurist Automotive Group. 97. Tesla produces many of its seats at its own Ziyad factory a few miles south of the main factory. 98. In 2020, due to the COVID-19 pandemic, Tesla implemented virus mitigation efforts in its Shanghai and Fremont factories. Shanghai resumed production on the 10th of February, while the Fremont and New York factories were to reduce activity by March 24. 99. 100, 101. On May the 9th, Tesla sued Alameda County in order to force the reopening of the Fremont factory. 102. Tesla told its employees that it had received approval to restart production in the week beginning May 18. 103, and the lawsuit was dropped on May 20. 102, as other U.S. factories reduced production during the COVID pandemic, the Fremont factory became the plant with the highest weekly production in North America at the end of 2021. 104, Elon Musk announced at the 2021 shareholder meeting, the 7th of October, 2021, that Tesla hoped to increase the production capacity at the Fremont factory by 50% in the next couple of years. 105, 106, manufacturing process. Overview. Tesla is highly vertically integrated and develops many components for its vehicles in-house, including batteries and motors. This is in contrast to many traditional automakers, who outsource many manufacturing steps to outside suppliers. 107. Design engineers also work at the factory itself, rather than a separate facility. 108, 109. Individual vehicles take between 3 and 5 days to complete the assembly process. 110. Drive unit construction. Motor construction. The alternating current induction motor used in vehicles are built by Tesla. The motors used in the Model S and X are built in-house at the Fremont factory. The motors used in the Model 3 and Model Y are built at Tesla's Gigafactory, Nevada, and shipped to Fremont. A complete Tesla Model S alternating current electric motor that has had a section removed from the stator to show the rotor inside. The main components of the motor are the stator and rotor. 111. The motor construction begins when a robot unspools and winds over 1 mile, 0.80 kilometer, of copper wire per motor. It then pulls the copper wire into a stack. The motor has 3 phases and so requires 3 coils of copper. 111. A worker then lengthens and straightens each bundle of wire and inserts a hydraulic lift to transfer the motor to the next station. A worker insulates each bundle of copper wire in a plastic sleeve to prevent the bundles from touching one another. The ends of the bundles are then snipped to the correct length. Lugs are added and crimped to form attachment points for the motor's 3 phases. 111. A specialized automatic sewing machine then binds the coils together to keep them in place. The increased tightness of the binding provided by a robotic sewing machine increases the efficiency of the motor. The stator is then encased in a 2-part epoxy resin to help in evenly distributing the motor's heat. The stator is now complete and is inserted into a heated metal case, locking the stator inside as the case cools. A worker uses a hoisting system to insert the rotor inside the stator, completing the construction of the motor. 111. Additional drive unit components. A worker then installs the differential and other sections of the gearbox, attaching it together using bolts. An air leak test is then conducted. The 3-phase triple power inverter is then installed onto the top of the motor to convert direct current from the battery into alternating current for the motor to use. The motor then undergoes a series of automated tests taking 4 minutes to ensure correct function, and then is moved to the general assembly area to be installed into the car. 111. The power inverter is constructed from metal oxide semiconductor, MOS, power transistors. Early Tesla vehicles used MOS-controlled insulated gate bipolar transistors, IGBTs, which have been replaced by silicon carbide, SiC, power MOSFETs, MOS field effect transistors, in later Tesla vehicles since 2018. 112. Battery pack construction. The Model S and X battery packs are assembled in-house at the Fremont factory using battery cells from Japan. Battery cells for the Model 3 and Y are made on-site at Tesla's Gigafactory, Nevada, and assembled into battery packs before being shipped to Fremont. Both battery pack types are liquid-cooled and contain an intumescent fire prevention chemical. 113. The battery packs for the Model S and X contain thousands of 18650 type cylindrical lithium-ion battery cells with nickel-cobalt aluminum cathodes. 114. 115. Tesla sources these batteries with a nickel-cobalt aluminum (NCA) cathode chemistry from Panasonic's factories in Japan. 116. The 18650 is a commodity cell, previously used in laptops and other consumer electronics, which stands in contrast to every other electric vehicle manufacturer who use specialized large-format Li-ion cells. 117. The Tesla Roadster, first generation, which was built before Tesla moved into the Fremont facility, also used 18650 cells. For the Model 3 and Y, Tesla uses larger 2170 type cylindrical lithium-ion battery cells. The larger size was optimized for electric cars, allowing for a higher capacity per cell and a lower number of cells per battery pack. 118. Tesla sources these batteries with an NCA cathode chemistry from Panasonic's production line at the Model S and X use thousands of 18650 type cylindrical lithium-ion battery cells, right? A smaller A battery is on the left for scale. Gigafactory, Nevada. 119. Body construction. Stacked side panels that have been formed on the tandem press line. Tesla makes extensive use of aluminum in vehicle body production. 111. 120. The Fremont factory takes delivery of large aluminum coils from suppliers, unwinds them, then flattens and cuts them into sheets in a blanking machine. Additional cutting is also done using a laser cutter. 110. A robot then transfers the aluminum sheet blanks into the tandem press lines where they are stamped into the various vehicle panels. The Schooler hydraulic stamping press line is the largest in North America and the 6th largest in the world. 27. The presses use up to 11,000-ton force to form the body panels. The upper section applies 1,400 tons of downward force and the lower section provides 130 tons of force. 111. The blank aluminum sheet is stretched over the lower draw die and openings are cut with robots transferring the panels between processes. In 2020, Tesla added a IDRA gigapress to the factory, allowing the automaker to stamp out single-piece area castings for the Model Y. 121. The workers then inspect each panel to ensure correct pressing. The parts are then stacked in frames and stored. The machinists press one part every 6 seconds and create 5,000 parts per day. 110. Final assembly. Tesla operates 5 general assembly lines in Fremont. 2 are dedicated to Model S and X production and 3 are dedicated to Model 3 and Y production. 122. On the assembly line, body panels are welded together. 123. The assembly line moves at a speed of 5 cm forward/s. 124. The car is raised and the drive unit is installed into the rear axle assembly. The drive unit provides power directly to the wheels without a drive shaft. 111. The battery pack weighs almost 1,200 pounds, 540 kilograms, and is delivered to the installation area and is raised into the car using a lift. Placing the battery pack under the cabin floor adds strength and rigidity to the car and lowers the vehicle's center of gravity. 111. To 18 inches, 46 centimeters. 125, 126. A titanium plate is installed under the battery pack which protects it in the event of a high-speed collision and to protect from road debris. 127, 128. Lawsuits and controversies. Sexual harassment. In 2021, 7 women came forward with claims of having faced sexual harassment and discrimination while working at Tesla's Fremont factory. 129.